It's woven into the very fabric of your digital life, often invisible but always present. From anticipating your next search to filtering your spam, Google's artificial intelligence isn't just a future promise. It's the quiet engine running the internet as we know it today. But how did a search company become the frontrunner in the most consequential technological race of our time? The story doesn't begin with chatbots, but with the fundamental need to organize the world's information. For over 2 decades, Google's core mission has been a massive AI problem, requiring algorithms to understand human intent from a few typed words. Every search query served as a data point, training their early systems to recognize patterns on an unprecedented scale. A pivotal moment arrived in 2012, originating from Google's mysterious X Lab. Researchers, including AI pioneers like Andrew Ng, built a massive neural network networked across 16,000 computer processors. They fed it 10 million random YouTube thumbnails, uncategorized and unlabeled. Without any prior knowledge of what a cat was, the network taught itself to recognize them with surprising accuracy. This cat neuron breakthrough was a stunning demonstration of unsupervised learning, proving that machines could find structure in vast amounts of unstructured data, a concept that lies at the heart of modern AI. Recognizing the immense potential, Google made a decisive move in 2014 that would reshape the industry. They acquired a small, secretive London-based startup called DeepMind for a reported sum between $400 million and $650 million. This wasn't just an acquisition. It was an injection of world-class talent and a new approach to AI. DeepMind's focus was on reinforcement learning, a method where an AI agent learns by trial and error to maximize a reward. Their early success in training AI to play Atari games at a superhuman level hinted at the power of this approach to solve complex, dynamic problems beyond simple pattern recognition. The world took notice in 2016 when DeepMind's AlphaGo program challenged Lee Sedol, one of the world's top players of the ancient board game Go. Considered excessively complex for computers, Go became the battleground for a historic showdown between human intuition and machine intelligence. AlphaGo's stunning 4-1 victory was a watershed moment, demonstrating that AI could master a game with more possible board configurations than there are atoms in the observable universe. It was a clear signal that Google possessed AI capabilities that were years ahead of the competition. While DeepMind pushed the boundaries of what was possible, Google was simultaneously building the industrial-scale infrastructure needed to power it. They realized early on that traditional graphics processing units, or GPUs, wouldn't be enough for the massive matrix multiplications required by deep learning. The answer was the Tensor Processing Unit, or TPU, a custom-designed application-specific integrated circuit built from the ground up for machine learning workloads. Introduced privately in 2015, these chips became the secret weapon behind Google's ability to train and run massive models efficiently. Google's infrastructure advantage is immense. A single TPU v4 pod, for instance, contains 4,096 individual chips, interconnected to function as a single, massive supercomputer. This allows Google to train models on a scale that few other organizations can even attempt. This computational horsepower enabled another critical breakthrough from Google researchers in 2017, the transformer architecture. This novel approach to natural language processing, detailed in the paper "Attention is All You Need," forms the foundation of virtually every modern large language model, including ChatGPT. The transformer's key innovation was its ability to process input data in parallel, rather than sequentially, vastly speeding up training. This architecture allowed models to attend to different parts of a sentence simultaneously, leading to a much deeper and more nuanced understanding of context and meaning. Armed with the transformer architecture and massive compute resources, Google began building a succession of increasingly powerful language models. In 2021, they unveiled Lambda, a model specifically designed for dialogue, capable of engaging in free-flowing, open-ended conversations on seemingly any topic. Lambda was followed by Palm, the Pathways language model, which demonstrated the ability to perform a wide range of tasks, from reasoning to code generation. The upgraded Palm 2, announced in 2023, was a beast, reportedly built on approximately 340 billion parameters and trained on a staggering 3.6 trillion tokens of data. But the race wasn't just about size, it was about capability. In late 2023, Google introduced Gemini, its most capable and general model yet. Unlike previous models that were trained on text and then adapted for other modalities, Gemini was built from the ground up to be multimodal. This native multimodality means Gemini can seamlessly understand, operate across, and combine different types of information, including text, images, audio, video, and code. It's not just reading about the world, it's perceiving it in a way that's closer to human understanding. Google's claims about Gemini's performance were backed by concrete benchmarks. On its release, the most powerful version, Gemini Ultra, outperformed OpenAI's GPT for on 30 out of 32 widely used academic benchmarks used to measure LLM capabilities. One of the most impressive feats was on the MMLU benchmark, which tests knowledge and problem-solving abilities across 57 subjects. Gemini Ultra was the first model to outperform human experts, achieving a score of 90% compared to GPT-4's 86.4%. Google also demonstrated Gemini's prowess in code generation, with the model achieving state-of-the-art performance on benchmarks like Human Eval. This capability is not just academic, it's being integrated into tools to help developers write better code faster. Recognizing that one size doesn't fit all, Google released Gemini in different sizes. Ultra for highly complex tasks, Pro for scaling across a wide range of jobs, and Nano, an efficient model designed to run directly on devices like smartphones. The ability to run powerful AI models on-device is a significant advantage. Gemini Nano on the Pixel 8 Pro, for instance, powers features like Summarize in the Recorder app and Smart Reply in Gboard, all without data ever leaving the phone. This on-device capability speaks to a broader strategy of integrating AI across Google's vast ecosystem of products. The company isn't just building models, it's embedding them where billions of people already spend their time. In Google Workspace, for example, AI is becoming a collaborative partner. Features like Help Me Write in Docs and Gmail use Gemini to draft emails, generate creative text, or summarize long documents with a simple prompt. The most significant integration, however, is coming to Google's core product, Search. The Search Generative Experience, or SGE, uses AI to provide comprehensive, conversational answers to complex queries, moving beyond a simple list of blue links. This shift to generative search is a massive undertaking, requiring a delicate balance between providing direct answers and maintaining the traffic that sustains the open web. It's a high-stakes evolution of the company's primary revenue engine. Beyond consumer products, Google is leveraging its AI prowess to dominate the enterprise market through Google Cloud. With an estimated 11% share of the global IaaS market, Google Cloud is seeing rapid growth driven largely by its AI offerings. Google's Vertex AI platform provides businesses with a unified environment to build, deploy, and scale their own AI models. It grants access to Google's foundation models, including Gemini, allowing companies to tailor them with their own data. Statistics show a massive surge in enterprise adoption. By early 2026, reports indicated that over 70% of organizations were already using generative AI in their cloud operations, with many choosing Google for its robust infrastructure and model selection. Google's impact isn't limited to the digital realm. One of its most profound contributions to science is AlphaFold, an AI system from DeepMind that has solved a 50-year-old grand challenge in biology, predicting a protein's 3D structure from its amino acid sequence. Before AlphaFold, determining a single protein structure could take years of experimental work. Today, AlphaFold has predicted the structures of over 200 million proteins, nearly every protein known to science, and made them freely available in a public database. This resource is accelerating research in everything from drug discovery to understanding genetic diseases. By late 2025, the original AlphaFold paper had been cited over 43,000 times, a testament to its revolutionary impact on the scientific community. Google is also applying its AI to the physical world through robotics. PaLME, a multimodal model, injects the knowledge of a large language model into a robotic control system, allowing robots to understand high-level commands. Instead of needing explicit code for every movement, a robot with PaLME can interpret a request like, "Bring me the rice chips from the drawer," and autonomously plan the sequence of actions needed to fulfill it. This convergence of language, vision, and action is a crucial step towards creating general-purpose robots that can operate in unstructured, real-world environments, opening up new frontiers for automation in homes and workplaces. But with great power comes great responsibility. Google has been a vocal advocate for the development of responsible AI, establishing a set of AI principles in 2018 to guide its work and ensure its technology is used for good. This includes building safeguards into models to prevent the generation of harmful content, addressing bias in training data, and developing tools like SynthID to watermark and identify AI-generated images and audio. The company is also acutely aware of the environmental impact of training massive models. They have made significant optimizations to their data centers and hardware, with TPU-v4 pods being far more energy efficient than previous generations. The race for AI dominance is far from over. Competitors like OpenAI, Microsoft, and Meta are pushing hard, each with their own strengths. But Google's sheer breadth, from research to chips to global product reach, gives it a unique advantage. The company has successfully merged its two primary AI research labs, Google Brain and DeepMind, into a single unit called Google DeepMind. This consolidation is designed to streamline efforts and accelerate the pace of innovation. Looking ahead, the focus is on building ever more capable and general agents. The recent introduction of Gemini 1.5 Pro, with its staggering 1 million token context window, allows the model to process vast amounts of information, like an entire hour of video, in a single prompt. This ability to hold massive amounts of context in memory is a game-changer, enabling entirely new applications in complex reasoning, long document analysis, and deep code comprehension that were previously impossible. The ultimate goal is artificial general intelligence, or AGI, a highly autonomous system that outperforms humans at most economically valuable work. While the timeline remains uncertain, Google's relentless pursuit of more general and capable models is a clear path toward that horizon. Google's strategy is not just about having the best model today. It's about building a sustainable ecosystem that will define the AI era. It's a full-stack approach, from the silicon in their data centers to the phone in your pocket. The company's vast user base provides a unique feedback loop. Every interaction with a generative AI feature in Search or Workspace helps refine and improve their models, creating a virtuous cycle of product betterment. While challenges remain, from regulatory scrutiny to the inherent unpredictability of AI development, Google's decades of investment and deep bench of talent have positioned it as the formidable force to beat. The AI race is a marathon, not a sprint. And in this long game, Google's combination of pioneering research, custom infrastructure, and ubiquitous product integration is proving to be a winning formula. From the early days of organizing the web to solving the mysteries of biology, Google's journey has been defined by tackling the hardest problems with information. Now, with generative AI, they are redefining what's possible. As these technologies become more integrated into our daily lives, the question isn't just who will win the race, but what kind of future they will build. Google's vision is one where AI is a helpful, ubiquitous companion, amplifying human potential. What do you think? Is Google's full-stack approach the ultimate winning strategy, or will another player take the crown? Let me know your thoughts in the comments below. And if you enjoyed this deep dive, please hit that like button and subscribe for more videos on the future of technology. Thanks for watching.